Take a look at this map of Gujarat, India. Tucked in the northern part of the state is the Banaskantha district. It's an arid agricultural region, meaning its survival depends almost entirely on catching and storing erratic, seasonal monsoon rains. To capture that water, the state relies on the Banas River and the massive Dantiwada Dam, built back in the late 1960s. The water held back by that dam dictates the local economy. It allocates irrigation for 18,000 hectares of farmland during the critical dry winter growing season, known as the Rabi crop. That guaranteed water security scales up, supporting major regional institutions like the Sardar Krishnanagar Dantiwada Agricultural University. The Dantiwada Dam is the engineered heart pumping life, food, and prosperity into the local economy. But there is an inherent tension in this system. The region relies entirely on catching massive amounts of water, yet the dam has a strict, finite holding capacity. In 1973, massive, sudden overflows caught local communities completely off guard. That event proved that when pushed past its breaking point, the exact infrastructure that provides life instantly becomes a deadly liability. How does a community survive when its greatest guarantor of prosperity also poses an existential threat? We saw this paradox play out in July 2017. An extreme weather event dumped over 617 millimeters of rain on the Banas River basin in a matter of days. The escalation of the flood was terrifyingly rapid. The river's discharge suddenly surged to a massive 6,438 cubic meters per second. The Dantiwada Dam's capacity was entirely overwhelmed. To prevent a structural breach, operators were forced to release massive overflows, sending floodwaters cascading into the vulnerable valley below. The physical concrete of the dam held, but the old methods of predicting and managing the water failed to match the terrifying reality of the disaster. To figure out exactly why those predictions failed, scientists turned to HEC-RAS, the Hydrologic Engineering Center's river analysis system, to forensically reconstruct the flood. Take a look at this digital terrain map. Researchers fed 30-meter resolution satellite topographic data into the software to build a highly accurate virtual model of the Banaskantha terrain. This graph shows the extreme water discharge rates recorded during the storm. By combining the physical terrain with these massive spikes in water flow around July 24th, the model begins to calculate exactly how the water behaved. The first output is flood depth. The model revealed flat floodplains acted as massive sinks, creating stagnant waterlogging zones. The second output measures flow velocity, identifying high-energy zones in the main channel where fast currents rip apart infrastructure. This map illustrates the third output, the total inundation extent. The dark blue boundary calculates that 73 square kilometers of land were submerged, pinpointing exactly which downstream and upstream villages were devastated. HEC-RAS took a chaotic natural disaster and broke it down into precise, actionable mathematical data. According to the Intergovernmental Panel on Climate Change, extreme hydrological events like the 2017 flood will only become more frequent. Yet Banaskantha cannot simply decommission the Dantiwada Dam. It is far too vital to their local food supply and economy. The modern solution requires leveraging the power of predictive data to outsmart the weather. This flowchart demonstrates how coupling these hydrodynamic simulations with geographic information systems creates a predictive pipeline for future storms. With these generated maps, local authorities can execute precision land use planning. They can physically move vulnerable assets and housing out of the modeled high-energy zones. They can also build highly effective early warning systems. By running real-time rainfall data through the model, officials can execute targeted evacuations long before the dam ever overflows. By fully integrating hydrodynamic modeling into disaster management, Banaskantha can break its cycle of ruin, ensuring the Dantiwada Dam remains a reliable source of prosperity rather than a looming threat.